Hi, I'm David and welcome to What Circuit. For this video we're going to do an equipment review. Specifically we're looking at a new bench multimeter from Hameg. Now this is one of the first instruments they've released in their new compact series. It's the HMC8012 bench multimeter. So this is the first of the new Hameg compact series and you can immediately see why it is. It's much smaller than some of the previous Hameg instruments we've looked at. In particular, the power meter that we looked at earlier. One of the major criticisms we had of it was just the sheer size of it. So it ended up taking up a lot of space on the bench and wouldn't fit on a shelf. And a lot of that space was just empty air. This one's much smaller, it's much shallower. This is going to fit on a shelf nicely, it's going to fit on the bench. Being a fairly standard Hameg enclosure, you've got 2 feet on the base, so you can retract these for use on the shelf. And it gives you quite a nice viewing angle on the bench. So let's get it powered up. So it draws a little bit of current when it's not powered up and the mains is connected to the back. I forget what the exact measurement is now, but it's not a great deal of current. The startup is fairly fast. It starts up in around 12 to 13 seconds, measurements we've taken, and doesn't seem to do any kind of cold boot procedure, hot boot procedure, doesn't seem to preload anything. Just seems to be generally fairly quick. I know this is actually fairly custom software it's running under here, unlike some of the Agilent stuff which uses Windows CE underneath. So the major feature you're going to notice is just a very nice looking screen on this. This is fairly unusually for certainly older series multimeters. This is a full graphics LCD, so much like the newer Agilent stuff that's coming through, but this is in a slightly lower end than the Agilent stuff. So you can see we've got 2 measurements at the same time here, which is quite common. We've got a third box here, we'll talk about that in more detail later on. It's going to be interesting how this LCD display comes out on camera, but I tell you, actually in person it looks very nice indeed. You've got lots of actual buttons to get to pretty much all the standard features that you're going to use. We'll see later you've got menus, quite shallow menus to get to almost every other piece of advanced functionality. And we've got the standard front input jacks here. So jumping straight into voltage measurements, we've got the unit powered on here. We've got it connected up to an external supply. At this point I'm measuring, if you hear some fan noise on the video, this isn't the Hameg multimeter, which is, as far as we can tell, completely silent. We got it hooked, the power supply hooked up to a highly accurate Agilent 19-inch rack power supply, which is buzzing away in the background. So we've got a DC voltage coming in here, so 5.1221 volts, and we've checked against some other meters and it's accurate, unsurprisingly. So one of the nice things they've got with this display is we've enabled a second function reading here, so we're also reading the ripple at the same time. So if we just go into the menu here, we can select what our second function is going to be. So currently we've got it selected on AC volts. We can also read DC amps at the same time, and we can do dB, dBm. Fairly standard stuff. dB, dBm, I'm just going to mention in passing, is nice. Unlike some of the other multimeters where it's calibrated against 50 ohm load, you can actually select which load you measure against. You can select it, on this case, against a 50 ohm, 75 ohm or a 600 ohm. So particularly if you work with audio systems and you're wanting to measure dBm voltages, that's very useful indeed. So we've got ripple on here. We can also do things like do an AC filter on there. So you can actually do some quite powerful stuff with the second reading. It's not just you get a number, you can actually work with it, you can actually put some filters on there and do some interesting stuff with it. So we've got the standard range select here. I'm going to leave it to an auto range at the moment, but you can set manual ranging if you'd like, if you're doing lots of similar measurements and you don't want it to take the time to auto range. Going through, we've also got a nulling functionality. So you've got a null button on the front panel, but you can also actually go through and type a value to null through if you want to. It's quite useful. ADC rate. So this is very similar to if you use Agilent equivalent NPLC, or number of power line cycles. So this just works out how fast your reading is updated. But as you can see here, as your reading gets faster, then the accuracy drops off slightly. So if you put it on fast reading here, so you actually get much faster updates on this, but at the expense of some accuracy, which is fair enough. The input impedance, it's quite an interesting one, this. So you can either set it to nice high input impedance, greater than 10 gig, which for a lot of low value measurements, high sensitive measurements, is very useful. But if you want to use external probes, particularly high impedance probes, which are a lot of time configured as a voltage divider, you can set it up so it stays on 10 meg input impedance and gives you an accurate result. So that's very useful. Now, particularly some of the Agilent handheld multimeters didn't stay at a fixed 10 meg input impedance, and therefore you just found you're getting completely incorrect results with high voltage probes. The auto zero, we're leaving it off here at the moment, but it's a nice little feature where it'll actually try and zero out any voltage loss in your cables and probes automatically. And then while we're through here, let's just have a jump into some of the other bits and pieces. This sort of measurements, you can also take it off a trigger if you'd like. So you can do a manual where you just press the trigger button on the front panel, and just at this point it's very nice to have a dedicated front panel button for this. So particularly if you're trying to trigger off a difficult measurement, you can just be sat there probing the work, bang, take your reading exactly when you want to. We'll just leave it in auto for the moment, and particularly when we're using some of the data logging functionality we're going to look at later, the trigger menu in this is very useful indeed. So looking at the third measurement functionality we got down here, if we jump into the measurement menu, one of the ones that certainly I use a lot is statistics, and if we look down here, it's quite small writing, but you can see it gives us minimum, maximum, mean, standard deviation, peak to peak, and how many counts it's working off. Now that's really useful for a whole lot of sort of long-term monitoring, logging, that kind of thing. And you see that's actually updated every time we do a reading there. So you see we're only up to about 60 counts at the moment, but if we want to, we could put this on fast acquisition mode for the ADC, start to build that count a lot quicker. And you see we're actually starting to get quite a lot more resolution than we are here, so it's quite a lot of resolution on there. So if I flip that off for the moment, on this mass measurement as well, we can also mass menu, we can also do limits, logging, which I keep on mentioning. We will cover that in a second. Now, one of the ones that particularly excites me, if I go back onto DC volts here, second function, let's take it off AC volts and put it onto DC current. Let's find connector here. So now we're measuring voltage and current at the same time. So the nice thing, we've actually got this hooked up for the moment just across the resistor. If we go into the measurement menu, we can put power on, and we can get a direct reading of power. Now the amount of times, so this is starting to emulate multimeters like the Metra Energy that can actually do this sort of thing. So let's say you want to have a device which runs off a battery, you want to be able to measure how much power it's drawing. You can now measure how much power it's drawing over a long period of time, combine this with the logging functionality. With this you can do averaging and all the usual mathematics on this. So if you're looking at current draw spikes or average current draw, this works very nicely indeed. So yeah, this, certainly for me, this is a really exciting feature, and one I've waited a very long time to see in a normal bench multimeter. Also very nicely implemented. We've checked this against readings taken from dedicated power meters and off sort of current and voltage probes, and it's spot on accurate. Lovely little feature, and something that's going to get a lot of use in this workshop at least. Okay, so moving through the functionality, let's have a look at continuity and diode measurement here. So we've got it on the continuity range, got a couple of probes, you've got the fairly typical settings, you've got a beep on and off, you've also got a threshold, which is quite nice. You can set that to quite a wide range of values. So particularly if you know you're looking, it's either, say you're buzzing out a cable, and you know if it's going to be either in the meg ohm range or the ohms range, you can bring that threshold up. Potentially that can speed up continuity, but as we're about to see, continuity is pretty quick on this. So if you just hit the probes here, So I'm not sure if you can hear that or not. It's because two things. Partly because we're running off the a mic just got clipped on here, and partly because the beeper on here isn't very loud. So that's a bit of a shame. So it's a very slight drawback, but the continuity function, whether you can hear it or not, it's very quick indeed. I'd say it's almost as fast as a lot of the flukes I've used. So very impressive, that. And the other one, the diode mode, just like to cover on here. So we've got some fairly nice, decent power LED here. So that's actually got a forward voltage of 2.5 volts. And that's actually illuminating it really quite nicely. Now the output voltage on diode test mode in this is 5 volts, which is a lot higher than certainly a lot of the handheld meters and quite a lot of the bench meters. With modern LEDs, sort of power LEDs, which got quite high forward voltages, that's a really nice feature, really well implemented. So yeah, very fast continuity and very useful diode test mode. Okay, so working through the rest of the features, we've got the fairly standard capacitance measurements on here. So just take a normal capacitor, get a probe in there, and it reads the value quite nicely. One thing I have been quite impressed about is its ability to read low value capacitors. So if I jump down here, so that's a nominal 2.2 nanofarad capacitor, and that's reading it quite capably. And it's going even smaller. If I can get good contact on that. So that's a 2 nanofarad capacitor there. And yeah, really working quite well. So that works down to quite a bit lower range than some of the other bench multimeters out there. So then, in a similar vein, we've got the ohms range. I won't go through this in great detail. Needless to say, we have gone through it quite slowly and painstakingly when we've been testing this, but in the end it's an ohms range. Just to give you an idea of the settling time there. So you see the auto ranging works really quite well. So we've gone from complete short to 33k there, and settles down really quite nicely. And again, you can speed that up if you increase the ADC rate, but it's going to drop down your accuracy slightly. I won't demonstrate it now simply because I've got to bring the probes along, but this setup is completely 4-wire capable in ohms and voltage mode. So if you've got the appropriate 4-wire probes, or you just want to hook some 4mm cables together, all works very nicely. So one of the features I've been using a lot of this multimeter is logging. So I've mentioned this in passing already a couple of times, but it's nice hassle-free use, which is what I really enjoy. So compared to some of the other, possibly slightly old bench multimeters I've used, where you have to query the instrument over LAN or over GPIB, and then you have to write software to do that, this one will log straight to a USB stick plugged into the front panel. So you've got a couple of measurements going on here. All I have to do is go into the measure menu, into logging. So we can select where we're storing our measurements to. In this case, we're storing it to front USB. And format, CSV. It's nice, really, really nice that you're using a standard format for these. So the format gives you either CSV or text. So this means when you're opening up on the computer, you can open up directly with either a text editor or straight into Excel. Particularly as contrasted to, say, some of the fluke multimeters I've used, both the bench ones and some of the handheld data logging ones like the 289. Now, those will log to a fluke proprietary format. You then open it up using a piece of fluke software, and then you have to export it to CSV or something like that. You can open up in Excel. This one, straight into CSV. There's no reason not to. I love it. Thank you. Compared to using some fluke stuff, which is just a pain in the backside, frankly. So that's actually get some logging going. So we've got that, we've got storage. So here we've got different modes. We've got U, N and T. So U just logs for an unlimited amount of time, and we'll just log until it fills up the USB stick. So in this case we've actually got a 16 gig USB stick plugged in there. We can log for days, weeks, months probably. N, you can actually set your number of samples to log, or T, you can set a certain amount of time to log for. So all three of those blooming useful. You can also set an interval on here. So we've got it set up for 0 seconds. That's just going to log as fast as the ADC can read. So let's turn logging on. So we're now logging into our USB stick. And also we've tried this out with lots of different USB sticks. As I mentioned, we're using a 16 gig USB stick at the moment. So far we haven't had any size USB stick that's failed to work at all. So yeah, it seems to work nicely. Okay, so just running through the connection to PC. First of all, we're going to cover connection via USB. So you can see HM Explorer we've got running here on the laptop. That's quite nice. This is the same bit of software that will communicate with pretty much every bit of kit Hameg does. So it's nice not having to install hundreds of bits of software. So it's found the multimeter. If we just bring that up, it gives us three options. So we've got CSV, which is fairly self-explanatory. This is just a way of bringing the logging data onto the PC directly. I won't bother with that one. We can grab a screenshot here. So this just brings a screenshot straight off the front panel. And you can actually do the same functionality straight to USB flash drive. Didn't mention that earlier. Takes a little while. It's actually running over a virtual COM port on this. So transmitting a image over serial takes a little while. So there we are, that's a screenshot there. And if you're looking at doing automated test equipment or something similar to that, this terminal was a really nice feature and one that I particularly like. So you can actually, let's bring CPI commands up here. So you can actually start to build up commands very quickly using the pre-built commands in this terminal. You can send them across, see what the instrument sends back, but this will also do things like logging exactly what commands you're sending across. So if you're starting to build up automated test equipment or something like that, you can prototype your functionality using the terminal before just bringing those same commands straight into your software, running it and knowing exactly what data you're going to get back. So very nice, very solid software. So here we've just dialed into the onboard web server and see some fairly basic information. We've got information about the device, we've got settings which are mostly actual LAN settings on there, and you can also set up security. Quite useful if you've got it as part of an automated test setup with several instruments running at one time. You've got device identification, which just sticks a box up on the front screen of the device. So on here, not particularly exciting, but I should mention that obviously this device does support LXI, which is LAN extensions for instrumentation. So you can actually send test and measurement commands directly over LAN, not through web interfaces or anything like that. The USB, we showed you the USB through the virtual COM port, which allows you to send commands, that sort of thing. You can also bypass that and send commands directly over USB, which is slightly faster and sometimes easier. So that pretty much covers the interfaces. So overall, this is a really solid performer as a bench multimeter. Really nice unit, been very, very happy with this, and we've been using this in the lab on quite a few projects for a little while now. It's been an instrument that you just inherently trust. And size-wise, it really lives up to the new compact series, so it actually properly fits on a shelf, fits on the bench without taking up half your bench. Really nice like that, and certainly compared to the power meter we looked at before, it's a really big improvement. So it's a 5 3/4 digit multimeter, so some of the competitors out there are pushing that a bit higher, 6.5 digits. What you do get, this is generally slightly lower cost than most of those. Also, the functionality on it is absolutely superb. In particular, things like using it as a DC power meter, being able to log the results, the statistics are all really, really nice. The firmware updates on this are great, and we've already had one through from Hameg. And yeah, there's some talk there about really making the most use of this, large, gorgeous screen that has, so during use, under lighting conditions, and even at quite an odd angle I'm looking at now, is very, very clear. So they've got a very good track record and actually supplying good firmware updates to the units later on in life. And I bought the Hameg oscilloscope coming up to 2 years ago now, and they're still putting out good, worthwhile updates and very few bugs in that. Right, well, some of the other strengths of this are the PC interfaces. You've got USB, you've got optional LAN, GPIB. Now, all of those are implemented very well. The support software for them is excellent. So let's say you want to use this as part of automated test equipment setups, that kind of thing. It's an absolutely superb choice. It's got example code, full programming manual for it. Absolutely excellent. The bad points on it: the continuity beep could definitely be louder. Inside, lab, particularly a multi-user lab where you've got several people going at the same time. And if you've got this up on shelving where it's a little bit further away from you, it could definitely do a bit more volume there. The probes that came with it aren't great at all, and frankly let down the multimeter a bit. Having said that, it's going to cost you not a lot of money, £15–20 to buy a new set of really nice quality probes. Get some Pomona ones, get some Agilent ones, whatever. They're going to be improvements, and compared to the cost of any bench multimeter, it really makes no difference at all. So overall, it's a really good multimeter. It's got really good features. The support for it is excellent. The display is fantastic. I've been using it in the lab for a long period of time and thoroughly enjoyed using it now. I would highly recommend this multimeter. So thanks very much for watching. We're going to be back fairly shortly with a video talking about an LED driver which we've got designed up. We've also going to have some new videos. A new workshop which we've been building is just coming to completion now. So we'll come back with that. We'll see you shortly. Thanks very much for watching. If you like the video, please click like. Thanks.